So for 4.8, we're just taking all of our trig knowledge and applying it to different real-life situations. So a safety regulation states that the maximum angle of elevation for a rescue ladder is 72 degrees. If a fire department's longest ladder is 110 feet, what is the maximum safe rescue height? For all of these, we need to draw a picture. So we have a building. It's on fire. I'm going to lean a ladder up against my building, and now I kind of have like my right triangle there. So I know that the maximum angle is 72 degrees. I'm going to set it at my max angle. It's 110 feet long. I want to know how high up can the ladder reach. Looking at that right triangle, that is going to be sine. So I'm going to set up my equation. Sine of my angle is my opposite over my hypotenuse. Oops, 110. I need to be in degree mode, so I'm going to double check my calculator, and then I can just type this in. And I got 104.6 feet. Make sure you include your units on here. Next, at a point 200 feet from the base of a building, so here's my building, I'm 200 feet away from it, the angle of elevation to the bottom of a smokestack. So the bottom of a smokestack is going to be on top of my building. So I'm going the angle of elevation up to the bottom of that is 35 degrees. And then the angle of elevation to the top of it, so from that same spot up to the top of my smokestack is 53 degrees. I want to find the height x of the smokestack alone. I am dealing with two heights here. So I have one height that represents just the building. So I'm going to find that out first. I'm going to call that y1. And then I have this other height that's the whole thing, building and smokestack. We'll call that y2. So my first triangle is for the building. For y1, I have an angle of 35 degrees. I'm 200 feet away. To figure out what y1 is, that uses the opposite and the adjacent. So that's going to be tangent of 35 degrees equals opposite over adjacent. Multiplying that out in degree mode, I'm going to get that y1 is 140.04 feet. Go ahead and set up your triangle and solve for that second one. So this went from the building, which I'm 200 feet away from, all the way up to the top of the smokestack. We're calling that y2. There, the angle of elevation was 53 degrees. Still using tangent because it's your opposite and adjacent. Solving that, I get 265.41. So that was all the way to the top. If I want to know just the smokestack, that should be just the difference between those two. So I'm going to subtract them. So my x, my height of my smokestack, should be 125.37 feet. The swimming pool is 20 meters long and 12 meters wide. The bottom of the pool has a constant slant so that the water depth is 1.3 meters at the shallow end and 4 meters at the deep end. Find the angle of depression of the bottom of the pool. So, I have a pool. Let's just draw my pool like this. It is 20 meters long and 12 meters wide. The shallow end to the deep end, rather, has a constant slant. So here's my depth of my pool if it was just straightforward. but it's not. One end is deeper than the other. So at the shallow end, since this one's less deep, that depth was 1.3 meters. Then it slants and goes to the deep end, which is 4 meters deep. I want to find the angle of depression at the bottom of the pool. So from my horizontal down, I want to find that angle. So to kind of zoom in on that, I'm going to draw my own triangle over here. Now that I have my big picture made, I want to find this angle up here. I know that all the way across the top, so the whole length of the pool was 20 meters. If the entire deep end is 4 meters, and the shallow end was 1.3, that drop was 2.7 meters. So it got 2.7 meters deeper. That's that side of that triangle. To find my theta, I'm using opposite and adjacent, so that's tangent. But again, you're trying to find your angle, so that's tangent inverse of 2.7 over 20. Make sure you are in degrees. I'm getting that my angle is about 7.69 degrees. Ship leaves port at noon and heads due west at 20 knots, or nautical miles per hour, that's all knots means. At 2 p.m., the ship changes course to north 54 degrees west. Find the ship's bearing and distance from the port of departure at 3 p.m. So, ship leaves port and heads due west. So I'm going to put my ship over here. And I'm just going to call this point A, because that's where it's starting. It heads due west until it hits point B. It's going due west at 20 nautical miles per hour. So from noon until 2, so that's 2 hours. 2 hours at 20 knots, or 20 nautical miles, which is miles on the water, per hour, should lead me to 40 nautical miles. So I have gone 40 nautical miles. From that point, it changes course to north 54 degrees west. So that angle there is 54 degrees. And I go that way until I hit point C. Find the ship's bearing and distance from the port of departure at 3 p.m. So this was at noon. I went straight west for 2 hours, turned to that north 54 degrees west until 3 p.m. So that's for an hour, still going that 20 knots. So this should be 20 nautical miles. I want to know, 1, my distance, and then 2, I want to know what my bearing is all the way back to here. So I'm kind of looking over here at these angles. Let's start with my distance. So typically when we name sides of triangles, like the side across from the B would be B. So I'm going to call that B. That's my distance that I want to know. Need to, I don't know, that's not really a right triangle. I need to kind of create a right triangle. So I'm going to change color just to help that stand out. So I'm going to come straight down and straight over. This side would be kind of across from A. This side isn't really across from anything, so I'm going to call it D. And I need to figure out what some of that is. So, this is 54 degrees. I know that north to west makes a 90-degree angle, so that must be 36 degrees. So let's start by finding this distance A over here, that vertical distance I've traveled. Let's see, looking at that triangle, the 36 is opposite it, the 20 is the hypotenuse. If you need to redraw your triangle to help you see that. I know that's 36, I know that side's 20, this is A, that's D. So I'm going to have sine of 36 degrees equals the opposite over the hypotenuse. So I'm getting that A is like 11.76 nautical miles. I need to go ahead and find D, because if you look at this, A, D, and then all the way across, that makes a big right triangle with the side I'm actually trying to find. So I do have that big triangle to deal with. So to find D, still looking at this little triangle, I'm going to use cosine this time. Cosine of 36 degrees is my adjacent side over my hypotenuse. So D is going to be 16.18 nautical miles, which means now I really have this big triangle with my A all the way to my C. This side is B, it's what I'm trying to find. This is now a right angle. This side was our little A, 11.76. This bottom has this piece here, which was the 16.18, as well as that 40. So it's actually 56.18. So now I have options. I could do Pythagorean theorem to find this piece here, which is totally an option. I could do, I'm going to call that theta, tangent inverse to find that piece. And then I could use like sine or cosine to find B, either one. It does not matter. I think you're all capable of doing Pythagorean theorem, so I'm actually going to show you the other way. Plus, I kind of need to know this angle anyways if I'm going to worry about my bearings. So when I do tangent inverse of that, I get that theta is 11.82 degrees. Now do remember, I want to know my bearing. So that from my ship to point C is north and then some degrees west. So for my bearing, that's north, some degrees west. This piece is the 11.82. So I want to know what's the outside piece. I'm just going to do 90 minus that. And I get 78.18. So north 78.18 degrees west. Now that I do know that angle on the inside though, again I could use sine or cosine. I'm just going to go with sine. So sine of that angle is equal to the opposite over the hypotenuse. If you did Pythagorean theorem, you should have gotten the same thing or very close, just depending on rounding. But I'm getting 57.1, and that would be nautical miles. That would be my straight distance from where I started to where I ended up.